between height or distance, also time, and acceleration due to gravity. Now, from your notes yesterday, you looked at information, you defined free fall, you looked at if something was in a vacuum, um, what would the acceleration due to gravity be? Like, how fast would it fall? Will it fall at the same speed as something else? And so you found that there was this new unit. Okay, this new unit. So typically we use a for acceleration, but whenever we're talking about it due to due to the force of gravity, instead of saying a, we use g. And this number here is the acceleration due to gravity on Earth. So this is the value on Earth. All right. And because it is the acceleration due to gravity on Earth, it's always going to be 9.8. You may see little differences depending on where we are. If we're on a different planet, this number is going to be different. The good thing is it's a constant. Okay. So it is a constant. And so whenever you're working problems, this value is not going to be given to you because you should know it. All right, and we'll use it so much that you will. You may see that this number is, they put a negative in front of there. And the only reason why they put a negative there is because the motion is going downward. Downward towards the center of Earth. Get all my words there. Okay. Now, there are two formulas that we use when dealing with this number. There are two formulas that we use. All right, and here they are. Okay, so what I'm going to do at this point is I'm going to define all of the variables, okay? And I'm going to let you know the unit, because I feel that if we can figure out the unit, all right, then you'll know what to look for in a problem. And once you identify what you're given and what you're solving for, you figure out which of these two equations you need to use, and it is easy peasy. All right, so let's just get started here. The first unit that the first variable, I should say, that we're going to define is v, and that stands for velocity. And that's going to be in meters per second, which we should be familiar with, right? Velocity is in meters per second. And if I'm going too fast, just let me know. G is acceleration due to gravity. I'm not writing all that, so I'll just write what that value is. Meters per second squared, so it's 9.8 meters per second squared. And look, we see it again in this equation, and it's still 9.8 meters per second squared. All right, our next variable that we're going to identify is the t in the equation. T represents time. It's going to be in seconds. And here it is times squared, but it's still seconds. And then we have one more variable to identify, and that is d for distance, or it may ask you for height, and that's going to be in meters. All right, so that would be all of our variables there. Okay, so we may either use this equation here, v equals gt, where we take acceleration due to gravity, multiply it by time, and that'll give us the velocity. Or if we're solving for distance, or as they say height, it's 1/2 acceleration due to gravity times squared. The only other thing I want to bring to your attention is sometimes you'll be asked to solve for time. So if we're looking at this equation here, and if you have to calculate the time and you're given velocity, what you're going to do is take velocity and divide it by the acceleration due to gravity. Okay. So I'm going to go ahead and give you that. Make sure you write that down. And then here, if you're given the distance, but I want you to find time, what you're going to do is you're going to do the square root of 2, well, I forgot to put this right here, time equals the square root of 2 times your distance over acceleration due to gravity. Okay? And we are going to work some problems, guys. We're going to work some problems, and we're going to use these problems. We're going to use these equations to work the problem. So we'll either use this one, this one, this one, or this one. Are you guys ready? Good.